Alrighty, good morning, everybody, and welcome to the wolfSSL live webinar on wolfCLU, our command line unit with Senior Engineer Jacob Barthelme. My name is Kaushal Sapkota, and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you'd like to ask the question live, as we do host a Q&A session following the presentation. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I also invite everyone to follow us on Twitter at wolfSSL, as well as all of our other social media. And please feel free to email us at facts@wolfSSL.com if you have any additional questions. And now I'd like to give a brief company overview before we move to the technical presentation. So wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source, dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2021, most of which are engineers. This progress is, of course, supported by a strong partner network that we're very proud of, which includes DDCI, STMicro, and Curl, for example. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, FIPS certification and a FIPS-ready offering, MQTT up to the version 5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSC support, and commercial support for curl. All of these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Jacob for the presentation.
Thanks, Kaushal. Yeah, as Kaushal had mentioned, we'll be going over wolfCLU, the command line utility, and I'm happy to dig in and share more about the wolfCLU option that we provide. So what is wolfCLU? wolfCLU is a command line utility for basic crypto and TLS related operations. It's an application that can be used to perform commonly done operations such as like generating a certificate, generating public-private keys, doing signing, verifying, hashing. It saves users the hassle of having to integrate the library's API into an application just to do a simple operation that they would commonly do. It can make hashes. We have multiple algorithms supported for hashing. Some of those being like MD5 for backwards compatibility, SHA-1. We also have SHA-256, 384, and 512. It can do some base 64 decoding, encoding, and it makes use of the wolfSSL library for all of the backend operations, all of its crypto and certificate-related, ASN-related operations. It can be both dynamically linked to the wolfSSL library or statically linked. It's under the open source license, currently under GPL v2, and it was written from the ground up by wolfSSL. So a little bit of the history behind wolfCLU. The first commit was back on January 5th, 2016. And that commit was made by my coworker, Caleb, who also works here with wolfSSL. It started out as a side project that he was working on. He had been doing a lot of our support cases at that time. And one of the frequent things that he had to deal with support cases was a quick way to make a certificate or a quick way to generate a key. And after having to suggest alternative command line utilities that weren't using wolfSSL, he decided to create one of our own in-house command line utilities to help out with our support cases and to help out with our users who were looking to do those simple operations like generating a certificate. In the early stages of wolfCLU, it was mainly it was a speculative project. A lot of interns would work on it over the summer internships that we do. They would be adding a new feature or a little bit of refactoring or a little bit of performance enhancements as some of the projects that we did with interns throughout the years. Recently, though, it has moved on to a more mature beta version, and senior developers' time has been spent more on the wolfCLU project recently. So why would you use wolfCLU? It's one of the reasons is it's an easy replacement if you're using the OpenSSL command line utility already. So it's an easy alternative to be able to plug into scripts that are using that OpenSSL command line utility. We have interoperability with our encrypt, decrypt. We also have the interoperability with the sign and verify. And the commands, for the most part, are very similar to the OpenSSL command line utility. So it's minimal impact to pre-existing scripts that make use of the command line utility. wolfCLU can also make use of our FIPS certified crypto in wolfCrypt. We have some of the best tested crypto out there available for doing our crypto operations. So you get the benefit of using that well-tested crypto, and also the benefit of using FIPS certified crypto if needed. There is also the benefit of the wolfSSL support and assistance. We have dedicated engineers that actually touch the code, that are able to answer questions or provide helpful tips or assistance. And then the wolfCLU code size is like a night and day difference between the OpenSSL command line utility. One of my later slides, I'll do a side-by-side comparison just to show how big of a contrast it is. And we also have portability in mind when writing our code. So it's very portable. Maybe you have some embedded device or some resource constrained device that it would be nice to have a command line utility on. wolfCLU would be a better fit than a lot of the alternatives out there for the embedded devices. And then the last reason I have listed here, I'm sure there's many more than what I have listed, but the last one I have here is it's an open source project. So you can get the GPL v2 version of it for free. It's up on our examples repository. There's also another location where it'll be shortly up in our downloads page. So the current supported features with wolfCLU, it's got an autoconf build system, which makes it nice for building it on systems that have support for the autoconf and automake. It also has key generation available, both ECC and RSA keys. Certificate creation and printout. So you can do some simple certificate creations with it. You can also print those out to the standard out and be able to view them with like the dash text option with the X509 mode. It also has a certificate request creation, hashing, signing and verifying. Multiple algorithms are included with the signing and verifying. It's the ECC RSA. In addition to those two, it has add 25519 for signing and verifying. That's one distinguisher between a lot of the other command line utilities out there. It has encryption, decryption, encryption and decryption with AES CBC, AES CTR, triple DES. As mentioned before, those are interoperable with the encryption that's done with the OpenSSL command line utility. One additional algorithm that we added in was Camellia for encryption and decryption. And then the last thing that I have listed on here is for benchmarking. It has some simple benchmarking. One of the things on our to-do list is to expand the benchmarking even more, but you can get a good idea of how fast or how long the algorithms are taking. So where to get wolfCLU? There's going to be two sources for downloading it. The current location for the wolfCLU source code is up on our wolfSSL examples GitHub repository. It's a subdirectory listed wolfCLU. And then a second location, which will be available shortly, is a bundle, kind of like a release bundle like we do with wolfSSL up on our download section. It'll be underneath the tab of view more downloads. So once you have a copy of the wolfCLU, this is the steps that you would need for building it and running it. The first step is building wolfSSL with all of the features enabled that wolfCLU uses. One easy way to do that is enable all. This enables basically every feature that wolfSSL has available. That's a lot more features though than what wolfCLU is using. Example being something like the CRL or some of the PKCS stuff that's not integrated yet into wolfCLU. So there's also a more targeted configure option that's in the wolfCLU README. An example of that would be just enabling what's being used here, the PWD based OpenSSL, all the keygen and cert stuff, DES3 and AES-CTR. Once you have built wolfSSL and installed it into a location that can be found by like include pass and when it's looking for wolfSSL during linking with wolfCLU, the next step is to go to the wolfCLU directory and run configure and make. If building from GitHub, then you'd want to run autogen.sh before running configure, but it's designed to be a relatively painless build. You just need to configure and make in the wolfCLU directory, which would then output a wolfSSL executable that can be used. This is a comparison of resource usage, like I mentioned earlier, a side-by-side between wolfCLU versus the OpenSSL command line utility. The simple operation being done here is just printing the public key from our ca-key.pem, and it's bundled with wolfSSL. So for only printing out the public key, OpenSSL took 161.4 peak kilobytes. This was with OpenSSL version 1.0.2G, which was the default that was on the system I was testing with. And then comparing that to wolfSSL linked with the wolfCLU, it only took 44.24 kilobytes of heap for the peak heap used. That's more than half of what less than half of what OpenSSL was using for peak heap usage. One of the features that wolfCLU has is version display. Why I put this slide in is to note that wolfCLU is actually bundled separately from wolfSSL. So when we're listing out the version, you get the version of the wolfSSL command line utility, and then it also prints out the helpful link to wolfSSL version. So you can see which wolfSSL version it's trying to use when it's running the wolfCLU operations. Our current version is 0.5 for the command line utility. The next slides will be going over examples of using wolfCLU. We'll have examples of running the benchmarking portion of the wolfCLU. We'll also have example of hashing, verify using public key. Then also certificate generation, printing certificate out to send it out. And then finally, an example of like the key generation. So benchmarking can be done with individual algorithms. It can also be done running all available algorithms at once. To be able to run individual algorithms, you'd use something like the first command listed there, the wolfSSL-bench AES-CBC, and then you can set the time in seconds that it would run. When doing encrypt-decrypt, you'd also need the input for the encrypted and output for decrypted file. At the moment, it just has AES-CBC, AES-CTR. We're still expanding the benchmarking capability to list individual sizes, such as if you're doing on 28, 192, or 256 keys. And then the next command that I've listed there is to run all algorithms. You can use the command -bench, again, setting the time, how many seconds it should run on each, and -all. And the printout on the bottom of this is just a couple of the algorithm printouts. It'll go through the AES-CTR, all of the hashing algorithms that it supports. An example of doing hashing would be listed below here. This is where it slightly differs than the OpenSSL command line utility currently. We're also going to integrate more of the same type of command, but right now it is listed as wolfSSL, and then you put the mode as hash, algorithm want to use, and then the text in. It supports MD5, SHA-256, as I mentioned, 384, 512, and base 64 encoding and decoding. One of the recent features we added was just the wolfSSL MD5 to be able to, you can pipe from the centered out into the command, into the executable. An example of that is like echo test and then being piped into the wolfSSL MD5. Yeah, and this makes it easy for users who are looking to get a quick hash. Say you downloaded a file from online and you got the SHA hash for it and just want to check the integrity but don't want to write a whole application for checking it. You could use something like this command line utility to just get that hash to be able to verify the integrity of what you downloaded. This goes over an example for verifying with public key operations. Assuming that you already have a signature from having signed some data, then you can run the command line utility dgst digest. So this would be the exact same command that you would run using the OpenSSL command line utility. You have the dash verify, which takes in the PEM version of the public key, which hash is being used. In this case, that was SHA-256. The file with the signature, and then the file that was signed. So in this case, it was test.txt. After it runs on that, it's going to print one of two things. It'll print either verify OK on success, or if it was unsuccessful in verifying the signature, it will print verification failure. So with the current certificate generation that we support, You have to use rec-x509-new, and then you can enter the number of days that the certificate will be valid. Then input also the key to be used, and have an output for where the newly created certificate will go to. In addition to the arguments listed on that command, we also support a configuration file. So those of you familiar with the OpenSSL command line utility know that it can accept in a configuration file for adjusting stuff like the subject alternative names, whether or not it's the basic CA constraints. Basically, the configuration file can adjust some of the different parameters for the certificate, and we support a lot of those configuration options from the configuration file, and we also support the same style and formatting as what OpenSSL would. So you can use the same configure file that you would have used for the OpenSSL command line utility in the wolfSSL command line utility. We also support the key usage, reading out the key usage from the configuration file. And if not providing a configuration file with the common name and country and state, there's also support for entering it manually. That's what's shown in the box at the bottom here. It can support entering the country, state, or province. Well, if a configure is not provided with those, then yeah, you'll be prompted on the terminal for providing the country, state, or province locality. And one of the features it has is if you just press enter instead of entering any information for one of those, it'll leave out like it'll leave it out from the certificate. In this example, the state or provenance where I left that blank, it would just not have that in the subject name. This is an example of the certificate printout. So for printing it out, the command is, again, the same as what the OpenSSL command line utility would do with the x509 no out -text and then -in with the certificate that you want printed out. Yeah, and that prints out a very similar format to what OpenSSL command line utility would. It gives you, the version, serial number, subject and issuer and validity. And then it also will give you some of the subject alt names. So if you have an IP listed as one of the subject alt names or a DNS, it'll list it there. Here we slightly differ from the OpenSSL command line utility. So our gen key, it by default will create two files when doing a key pair. So this example will generate a 2048-bit RSA key and place the private version of it into new key.priv and the public version of it into new key.pub. You can specify with -output whether you want only the public version, only the private version, or both, public and private. We do also have the EC param mode, so you can do /wolfSSL EC param, which will generate it more similar to what the OpenSSL command line utility would, at least for the ECC ones, wherein that'll accept in like the curve name. So you can do something like the CCP 384R1 or some other named curve that you'd like to generate. One of the other things that this will support is if you want the exponent, you can set it to a specific size. We default to the exponent of 65537, at least with RSA. With RSA, we default to that. That goes through all the examples. There's a lot of additional stuff that we'd like to see in the wolfCLU. I have some of the upcoming roadmap items for wolfCLU. One of the things that we're toying with is quantum resistant algorithms tied in for sign verify. We also would like to see some of the PKCS operations. We have PKCS 7, 8, and 12 on our upcoming roadmap. In the wolfSSL library, or I should say bundled with the wolfSSL library and the wolfSSL directory, we have our client and server examples. One of the things that we're considering at the roadmap items for wolfCLU is having those client and server examples be part of like the wolfCLU instead, or at least more comprehensive client server example or applications in wolfCLU. This would be similar to like the S_client, S_server to be able to just run a TLS code connection relatively quick. We also have Windows building and testing on our upcoming roadmap item. So far, it's been tested thoroughly on Unix-like environments, Mac OS and Linux. I'd like to add Windows building and testing to wolfCLU. Can always get more and better testing. Would like to do an expansion of our automated testing with wolfCLU. That's one of the items on our upcoming roadmap. And then an embedded device example and use case would be one of the last items that we have listed here on our roadmap item coming up. I put FreeRTOS on port as an example, but when we get to the point where we're doing the embedded device example, we might be using something other than FreeRTOS. But this would be FreeRTOS running on one of the numerous NXP devices that we support with wolfSSL, or maybe an STM32, something that's more resource constrained than like a laptop. We also value the feedback that we get from people, such as what feature requests that our users would like to see, or places where our users see that it could be changed to be more easy for using. And if you have any feature requests or suggestions on ease of use, you can send those into facts@wolfSSL.com, and an engineer will respond back to you about it. And that's all I have at the moment. I think we'd like to go ahead and open it up for any questions that have come up about wolfCLU.
Thank you, Jacob, for a wonderful presentation on wolfCLU. As a reminder to everyone, this webinar is recorded and will be made available to our YouTube channel following this presentation. If you'd like to receive the slide deck, please feel free to email us as well at facts@wolfSSL.com, and we'd be happy to send that over. And if you have any other questions or comments, also please feel free to email us at facts@wolfSSL.com, and we'd be happy to help you. Thank you so much. Hope you have a great day.